Okay, so for question number 9, what we want to do is we want to take the formula that we use to calculate the value of the truck and switch it to being able to calculate the time related to the value instead of the value related to the time. So remember, with inverses, what we're really trying to do is trade places. So we're working in the opposite direction. And how we're going to do this is first, I'm going to write my original function, v of t equals negative 2.3 over 12 times t plus 34.5. That's the equation that we started with. And I want to make v of t y and then replace our t with x. Now, if I want to take the inverse, the first thing that happens is x and y trade places. So now I have x over here, I have y here. Now our next step is to solve for y. If I get y alone, I've got the inverse of the function. So I have plus 34.5. I'm going to subtract 34.5 from both sides. So I have x minus 34.5 equals negative 2.3 over 12 y. Now, in order to get y alone, what I want to do is multiply by the reciprocal. So I put the 12 in the numerator with the negative, I put the 2.3 in the denominator, and those two things will cancel each other out. And if I do it to one side, I have to do it to the other. Now, my final step is just to clean this up and rewrite it without the fractions in front of the y. So now y is alone. Once y is alone, I can rewrite it in terms of what I wanted to know. So the time based on the value of the truck, t of v, is a function of the value of the truck. And that's how we find the inverse to the original function. Now, if you notice, we got a little bit of a hurry in class, and this was actually a positive, and that's why I made this video, is to show you where the negative 34.5 comes from. And now we're going to go to our graphing calculator and graph this. So first thing I want to do is set an appropriate window. So my window for this, I'm going to start with negative 5 because I want to see the y-axis and I want to see the x-axis. And remember, the months go up to 180, so I have to go to 185 for both. And here I'm going to count by tens just to make a nice readable graph. So that's my window. Now I'm going to put in my two functions. Our first function puts in a time for x and finds a total value of the function. That's f1. Our second function puts in a value and calculates the time based on a specific value. That's f2. Now, one thing that the questions are asking for is, where do these two lines intersect? So if I do menu, analyze graph, intersection, their point of intersection is 28.951. And the one thing that you need to notice from this question is 28.951 is the x value and the y value. So what they're saying is when the truck is worth $28,951, 28.951 months have passed. And the key to this is X and Y are the same. So the next thing that they ask us to do is graph the line Y equals X. Notice that this point is on that line. And these two functions that we've graphed actually have a relationship based on this line. And that relationship is that these are reflections over the line y equals x. So when you think graphically about a function, if you want the inverse of the function, you reflect across the line y equals x. So this is the graph that you should have with number 9. Number 10 just asks us to sketch that graph, which we already really did in number 9. So what we want to do is talk about how the graphs compare. And the way the graphs always compare is X and Y have traded places, right? The input for the original function becomes the output for the inverse function. Now, what is the meaning of the intersection point of the two graphs? We talked about that. At 28 months, the truck has a value of 28.951 thousand. Now, for 12, what they ask us to do is add the line y equals x. And the last thing you're being asked to do is describe that relationship, which of course is the inverse is a reflection over the line y